Hey everyone, Krishna this side and I welcome you all to this channel. So let's solve this LeetCode question 1504, count submatrices with all ones. Let's read the question. Given an m cross n binary matrix mat, return the number of submatrices that have all ones. Okay, I think the question is not so clear, but when we see the examples, we see that they are just trying to ask us. We just have to consider the rectangles, okay, that are available in this one. So area is basically called as a rectangle, or submatrix is called as a rectangle if it has all elements filled with one. Okay, so I'll explain you what it is trying to ask us and what we have to achieve. So when we see the constraints, this m and n basically goes all the way to 150. So any brute force approach that comes in our mind, it should perfectly work fine. But of course, we should have idea about the optimized solutions as well. But in this particular video, I'll just target to explain the brute force solution. In next video, probably in the evening time, I'll create another video explaining you the optimized solution. So there are multiple questions available in this particular type of pattern. So I'll point you guys those questions as well so that you can practice those questions along with this one. Okay, let's see. Let me connect the screen first. So here we got this particular matrix. Okay, let us suppose, and we just have to consider all different rectangles that are available. Okay, so here when we start counting, individual element can be rectangle, right, having length and width as 1 cross 1. Okay, that can be rectangle probably. So those are like, here it is one rectangle, second, third, fourth, fifth, sixth, seventh, eighth, in total 8 rectangles we notice here. Okay, so 1 cross 1, in total 8 rectangles we have. Okay, next is like again when we see there, this is also not rectangles, these are rectangles, correct? So in total here 1 cross 2, there are 4 rectangles that are available. Okay, so 1 cross 2, 4 rectangles we identified. Next is again like these are also rectangles, like this one rectangle, second rectangle, fourth rectangle. So in total 2 cross 1, 4 rectangles also we noticed. Okay. Okay, apart from this, do you see any other rectangles? Yes, there are rectangles, right? Like this is also rectangle, this is also rectangle. So 1 cross 3, in total 2 rectangles we identified. Again, this is also rectangle, this is also rectangle. So 3 cross 1, 2 rectangles we identified. So in total, total rectangles are like, apart from this, we don't have any other rectangles, right? Like we cannot consider this 0 value in any of the rectangles that we are trying to form. Okay, so in total they are like 8 plus 4 12 plus 4 16 17 18 19 20. In total 20 rectangles we identified. Okay, so far 20 rectangles we saw here in this particular one. So that is something what we have to return into the output. Okay, I guess the question is clear. Let's try to see how we can solve this one. Let me clean these stubs. Let us suppose this is the matrix that is been there. So what we will do is, I already explained you one thing, right? Like when we have given this type of area and we have to just count how many rectangles that are there. So what we basically do, here it was 1 2 3, we simply add them. In total 6 rectangles will be there. So how they are, like it is 1 2 3, then this is again next one, this next one, and entire area can be rectangle. So in total 6 rectangles that we can easily identify. Okay, so same logic we can apply column wise. Okay, column wise we can apply that logic. But again, if we try to apply the same logic row wise, okay, then in that case rectangles will start getting duplicated. Okay, because in this particular area, in total 6 rectangles that are there. Okay, it is fine. Again, in this particular, only in this particular area, in total there are 3 rectangles that are there. Those are like this one, and entire can be rectangle. Okay, so column wise that approach is fine, but again when we try to apply the same logic row wise, okay, the rectangles will start getting duplicated. Because any particular rectangle, let us suppose this particular rectangle we already consider in this particular column. Okay, but same thing when I try to add, like here it was 1, so again 1 I noticed, so count was basically 2. So when we try to add them, it is 3. Here in total like 6 is something what we got it, and in this way 6 is also we got it. But here this particular one is something what we again consider in this area as well. Row wise also we actually considered the same area, okay, which we already counted in this way. Okay, so slight modification is something what we have to do while going to the next column. So column wise this particular approach is completely fine, so we can get it in total 6 rectangles. So whatever the height so far that we are getting it, here the height was initially 1, here the height was basically 2, here the height was 3. So whatever the new answers that we are getting it, those we can add it into the simply an answer variable. Okay, in total so far 6 is the answer that we got it. But going ahead again, here for this one same logic we will apply while going downside. But from here also we are missing few of the rectangles, okay, because it is now two-dimensional array, right? So two-dimensional matrix is something what we have. So obviously here these whatever the area that we are missing it, for them we have to perform some calculations, okay. So that is something what we will try to see, because going downside this logic can perfectly work fine, there is no doubt at all. But these elements, these, okay, these whatever the remaining rectangles that are there, that those also we have to consider, okay. For them, how to consider them, that is something what I'll explain you, and this is basically a brute force approach to optimize solution. I'll explain you in other video, okay. Let me clean this up, and what we can do is we will maintain a DP array to track all the heights that we are getting it while going downside, okay. And that we can utilize while we were into the next column, there also we can simply utilize the same whatever the previous values heights that we got it, based on that we can easily calculate the things, okay. So let me clean this up and let me prepare the DP array. Okay. So what we will do is basically we will start going column wise. Okay. So whatever the elements that are available in the column, those we will keep on exploring it and performing the operations. Whatever the height that we are getting it, we will keep on updating it into the DP array, as well as we will maintain an answer variable where whatever the so far different rectangles that we explored, we will keep on adding it into the answers. Okay. Now in the DP array, initially whatever the value at top that are there, those values should be available same as it is, because whatever the height initially that we have, we cannot alter those values, right? Like we don't have any further height going ahead, right? Because here whatever the elements that are there, those are the height that we can get it initially. So initially at this particular index, one is something what we have failed, okay, because this particular row is basically 0. At 0th row we cannot get any different heights. Now at this particular location, only a single rectangle is basically formed. So one is something what we have added it into the answer. So answer is basically got updated with 1. Okay. Now when we move downside, okay, when we are at this particular index, okay, so we check that if the value is basically 1, okay, at any point in time, if value is 1, then that means we can generate a rectangle at that location. So what we will do, whatever the previous value in the DP array that we have, we will add 1 into that value. Okay, here it is 2. Because again, like the logic is same, I already explained you like that logic where we will keep on tracking rectangles 1 2 3 and we will add them at the end. The same thing that we are trying to do right over here. Whatever the DP array previous value that we have, we will simply add 1 into that one. So here only if 1 is something what we notice, if 0 is something what we have, simply update the DP array with 0, because going downside, if here 0 is something what we have, I cannot generate a rectangle with this one. Okay, so obviously 0 is something what we have to update at that particular location, right? So here since there was a value, so 2 is something what we have updated and we will simply add it into the answer. So far the answer was updated with 3. So only if we got this particular area as a matrix, okay, this is the area that we got it as a matrix, then answer is basically 3. Okay, we can easily mention that. So at any point in time, what at particular any particular index, so far the answer that we got it, that is going to the correct and exact answer that we are getting it. Okay. Okay, once we are done with this, we will shift to the next row. So here it is again 1. So whatever the previous value that we have, we will simply add 1 into it and we will update here. So here the value is basically 3. Okay. Now the moment we update into the DP, we can simply add it into the answer. So far the answer was 6. So only this area is something what if we got it. Okay. So far if that is the only matrix that we got it, so answer was basically going to be 6. Okay. This is fine, right? Now moving ahead to the next column. We'll perform the logic same, like at any point in time. Here let us suppose again 1 is something what we have. So 1 is the value that we have to update into the DP array at 0th row, and this one we have added it into the answer. So answer was 7. Now we have to check, is it possible to generate any rectangles with the previous columns as well? Okay, so obviously here this is a rectangle that is possible. But now since we already consider this one, okay, this one was previously considered and got updated into the answer, right? And this is the new, that is something what we have added it into answer as well, correct? So only concern was this particular one, right? To generate this particular one, what we can do is we can simply check what is the minimum value out of them. Minimum value, why we are considering, just let us suppose This is the area that we have in. Let me change the color as well. Here, this was the area. Here it was 1. Okay, and we are currently at this particular index. Okay, now when we try to generate rectangle with this, considering this one, okay, considering this one, we have to consider this one because previously whatever the rectangles that we can generate, all those rectangles we have added it already into the answer. Okay, we have already added. We have to check with this particular one what are possible rectangles that we can generate. So here for this one individual also we have already added. Now only concern is like with the previous rows, okay, with the previous column, sorry, with the previous columns, can we generate any rectangles considering this one? Okay, that is the goal. So here this is the only rectangle that is actually possible. Okay, so that for that one we will simply check what is the minimum value out of them. So here the minimum value is basically 1. So only a rectangle that is possible was this one, correct? Having this area. Because here I cannot just say this is a rectangle, right? This is not a rectangle, right? Only rectangle possible was this one. So out of these two, minimum value is what we check, and that is something what we will update into the answer. Let us suppose if the area was like this, that means in the DP array 2 2 is something what we have failed. Okay, going ahead you will get this particular one. So I am already explaining you. So 2 2, that is the height that we got it into the DP array. Okay, and we have to consider with this particular 2 what are possible rectangles that are available here in this one. Okay, so when we consider minimum out of them, 2 is the minimum value that we are getting it because both the values are 2. So here two rectangles, different rectangles that are possible. The first one is the entire rectangle. First one is the entire rectangle. The second one is only this area. Why only this area and we are not considering this one? Because this particular area we already calculated and stored it into the answer. That was this one. Okay, I'll explain you. I'll get back to this one again. Let me clean this up. But for now, you get it right. Like why we are considering the minimum value out of them. Based on the minimum value, we will simply add it into the answer. So we are actually running another for loop and going backside. And we will keep on checking what are the minimum current values so far we got it. And based on that, we will simply add it into the answer. So answer is basically now here out of these two, minimum was 1. So only a single rectangle was possible. That is something what we have added it into the answer. The answer was 8. Okay, the answer was 8. Now once we are done, we will shift to the next row. So here it was 1. So whatever the previous DP value that we have, we will update it. 2 is something what we got it and we will update it into the answer. So far 10 rectangles we saw. Now at this point in time, what are the different rectangles we already explored? For here all the possible rectangles, here this one is already be explored, this one is already be explored. Now since 2 is something what we have added it, that means this rectangle and this rectangle is also we have explored. Only left out rectangles are this one, this one, correct? So to count these two different rectangles, what we can do is again we can go in the back side, and we have now height as 2 2, height as 2 2 at this point in time. Okay, just trying to represent it into the pictorial formation. So now based on this one, right? So here what are the only rectangles that are left out? Because we already sorry, let me switch it. So here this one and this one, only two rectangles that are left, right? So what we can do is we will go in the back side and check what is the minimum value out of these two. The minimum value is basically 2, and that is something what we will update into the answer because only two rectangles that we have to explore, and this way we will getting clarity. Okay, whatever the minimum value out of the two that is there, those only rectangles we have to cover. Like here, as I was trying to say here, this was 2 2. So entire rectangle is something what left out, and this is the area that is left out because this area is already something we have covered it here. This area is something what we have already covered it in the backside. So this is something we are not concerning about right now. So only two rectangles possible at this point in time. So 2 is something what we have added. In total 12 rectangles so far we explored. Going ahead, here we notice 0 as a value. So here simply we will update with 0. The moment we see 0, we will simply continue from there. So we are now at the next column. So quickly let's try to fill these things because it is easy once you get the idea like what we are trying to do, you get the answers. Okay, so here again 1 is something what we have filled, 1 is something we have updated, 13 is the answer that we got it. Now we will try to see what are the possible rectangles that we can generate going backside. Okay, we will simply go backside. here one rectangle is possible and entire rectangle is also possible. That means like in this particular area, two rectangles that are left out still. Okay, because all the different rectangles, this is something what we have covered it, this is we have covered it, this is we have covered it. So this is also individual we have covered it. Now only rectangles that needs to be covered are this and this. So we will simply run a for loop. We will keep on going in the backside. We will check that between these two, which is the minimum value. The minimum value was 1. So only a single rectangle is possible. So 1 is something what we have added it. 1 is something what we added. The answer is 14. Now the minimum value got updated with 1. Okay. See, we have to keep track of minimum value as well. Going backside, because see, at any point in time, let us suppose we have this array 2, 1, 2. Okay. The height was basically 2. Here it is 1. Here it is 2. Correct. Here it is 2. Now, in this area, okay, this is one rectangle that is possible. This is one rectangle. So out of these two, minimum value was 1. So 1 is something what we have added it into the answer. Now, when we try to cover this one, okay, in this one, this is also another area that is something what we have to consider, because that is the only area that generates a rectangle, right? So we will keep on tracking while going backside. We will keep on tracking like what is the minimum value. So far we got it, because again here when we consider this is like only a single rectangle that is possible, right? And I cannot directly generate this any rectangle possible, right? I have to consider all these areas, then only a rectangle is possible. So only area here it was 1. So out of these two, minimum was 1. So 1 is something what we have added it, and we will update the minimum as 1. Now again 1 with these two, we will check which is the minimum. 1 is already the minimum, so that is like one rectangle is possible. Those rectangles are like possibly this one and this one. So we have to keep track of minimum value as well, so while going backside for loop that we are running it. So here currently the minimum was 1, and this was the one area that is something what we have considered. Okay, and we updated it into the answer. The answer was 15. Now again, this is the area, new area that we have to consider, because the minimum value is 1 and here also 1. So in total out of these two, minimum was 1. So 1 is something what we have added it, and we have to add it into the answer. So that rectangle is also got covered. So for the answer was 16. Okay, now when we move into the next line, okay, here it was 1. So whatever the previous dp value that we have, we will add it 1 into it. So 2 is the answer that we got it. Now 2 is something we will append it into the answer. So answer is basically 16 so far. That is something what we have. Let me clean this up. So 16 plus 2 is basically 18. That means these two rectangles we have considered. Okay, these two rectangles we have considered 2 when we add it, because this particular one we already added it into the answer. Okay, so here it was two rectangles we considered. Now going in the back side, how many possible rectangles that we can generate, that is something what we have to check. So here we will compare with these two. The minimum was 2, so minimum got updated was 2. So 2 is something we can update it into the answer. So answer was basically 20. And those rectangles are like when we added 2, that means like this was one rectangle and this was another rectangle. Okay, the entire value, or this one, these are the two rectangles that are possible, because all the other rectangles we already covered it, any possible rectangles, right? So now once it is done, the minimum was 2. So this minimum and this value we will check again. Two rectangles only possible, so those rectangles are this entire area and this is another area. Okay, this is another area. Okay, because we already covered it, these rectangles, whatever the left out rectangles that are there, we already covered it. So minimum out of them, that is something what we have to consider. So 2 is something what we have added it. Answer was 22. So in total, so far we got 22 rectangles. Now next row is basically here again. It is 1. So whatever the previous value that we have, 3 is something what we have. 3 is something that we will add it. 25 is the answer that we got it so far. Okay. Now when we try to go backside, we notice 0 is something what we have. The moment the minimum value is basically equals to 0, we will simply break it, because we cannot generate any rectangle in this area, right? Because here it is nothing, right? So the idea is here it is 3. Here it is at ground level, and again let us say that this is 3. Here it is 0 and again 3. So what are possible rectangles here in this particular area? Nothing, right? Like we cannot generate any rectangle in this area. So obviously the moment we notice 0 or the minimum value that we are tracking out, if it is 0, we'll simply break from there. I think the idea is pretty much clear. So we will keep on tracking these rectangles, and at the end we will get the answers. I hope the idea is pretty much clear what we're trying to do. Let us try to write down the code as well, because it is taking a lot of time now explaining the same things again and again. So starting with first thing, like let us try to get row, or let us say m is basically equals to 0, n is basically equals, sorry, it is not 0, but mat of length, and n is basically equals to mat of 0 dot length. And as I said, we will maintain a DP array, new int. Okay, in the DP array, what we can do is it is like m cross m. That is the DP array that we are maintaining it. We'll run a for loop for int I equals to 0, I less than this m, I plus plus. Next for loop is for int j equals to 0, j less than n, j plus plus. The first thing is if I is basically equals to 0, what we can do is we have to simply update in the DP array whatever the value that is there. So it is like matrix of I and j. Else what we can do is we'll update this DP array based on this matrix value. If matrix of this I and j, if it is equals to 0, we have to simply update 0, or else what we can do is DP of whatever the above row value that we have, right? So I minus 1 and j plus 1. Okay, I think that is the whole idea behind it, right? Like we were just tracking out the height so far that we got it. The moment we got the height, what we can do is let us create here answer variable. Answer equals to 0, we will simply add it into the answer. Okay, whatever the answer value that we got it. So answer plus equals to DP of I and j. Once it is done, what we can do is we can take a minimum value DP of I j, and we can run a for loop for int this is like k equals to I minus 1, because from the back side of this index we are running a for loop, right? I should be greater than equals to 0 and I minus minus. So here what we do is we will simply check this minimum value. Minimum equals to math dot min between this whatever the minimum value that we have and this DP of I and j. Okay, sorry, it is not I, and it is basically previous index is something what we are tracking out, right? Like that is going backside. So I basically the row is going to be the same, but the column is something what we are shifting backside. Okay, and it should be I, right? It shouldn't be I, it should be j, because we are tracing backside. Sorry, it is k, and this is k, what I have written. Okay, so we got the minimum value. Okay, because we are at same row, but we are just trying to go in the backside, and we will simply track the minimum value. If this minimum is equals to 0, we simply break it, because going back there is no point, right? And if not, we'll simply update it into the answer plus equals to this minimum value. Okay, that's it. Like we don't have to do anything else. Once it is done, we can simply return this answer is something what we have to return. Let's try to see if it is working fine or not. There is an error. So minimum is something we have to define, right? Int minimum equals to DP of ij, and there is another error, k again. Here it should be end, right? So yeah, int k equals to j minus 1 k, basically, right? It is getting accepted. Let me try to submit and see if it is working fine or not. So talking about the complexity here, these outer loops are basically m cross n. Again, this inner loop is basically running all the way to n times, like how many columns that we have. So it is like m cross n cross m cross n cross n. That is the time constant that we have. Space is obviously m cross n. Okay, there is obviously a better solution out there. We can use monotonic stack. With that also we can easily solve this one, and it basically optimized version. And I'll explain that particular solution in the next video. Okay, probably if possible in the evening time I'll make the video. Okay, thanks for watching this one. Bye bye.